Hi Charlie, what's up?
Hi Ash. See, I'm like trying to understand the Poiseuille law, but it seems like a mathematic equation to me.
Okay.
I'm not able to correlate this law with the blood flow. Could you please explain me?
Oh, okay. It's just you just have to look at the formula. Like here, you can see the blood flow is directly proportional to the radius of the artery and is inversely proportional to the viscosity of the blood and the length of the artery.
Sorry, I didn't get it. Can you please elaborate it or
Um,
anything?
okay, I can explain you with one experiment. Let's just try that. Okay, let's get to the straw. I'll show you with two different straws. So I have a thin straw and I have a thick straw, like with two different radiuses. And then I have also two cups. So what I'm going to do is I'm going to insert this straw into the cup. As now we have made two cups, the artery with the large diameter and the artery with the small diameter. Let's make some blood. Now as we have the same amount of blood, we're going to pour them into two different arteries and we're going to look at the velocity of the blood. Now here we can see that the blood flows faster through the artery with the greater radius as compared to the artery with the smaller radius. Let's have a look over here. We have a cross section of artery and a deposition of plaques onto the same artery. And as you can see that the deposition of plaques onto the artery has reduced the radius of the artery. And as the radius of the artery is bigger over here, it has a higher amount of blood flow. And as the radius of the artery decreases over here, the blood flow also decreases. Therefore, we can say that blood flow is directly proportional to the radius of the artery.
Okay, Ash, I get it about the radius, but how about the viscosity? Could you please explain that as well?
Yes, I can explain that with the similar kind of experiment, but if you help me with the viscosity of the blood.
Sure. To make the blood thick, let me add some clay to the fluid.
As now we have two liquids, one with more viscosity and one with less viscosity. So we are going to pour them into the cup through the straws. And we have the straws of the same diameter. So we are going to put them and look how fast does the non-viscous fluid goes. You can see onto the right side that the viscosity of the blood is lower and the blood flow is higher. And if you see onto the left side, the viscosity of the blood is higher and the blood flow is lower even when the radius and length of the artery are the same. We know that the blood is composed of plasma and blood cells, and plasma has number of fats and proteins. Now we have here two arteries, artery A and B, which have the same length and the same radius. And as you can see, the number of RBCs in the artery A are lower, which is called the lower hematocrit value, and the number of RBCs in the artery B is higher, which is called the higher hematocrit value. And as the number of RBCs is higher, this will be able to generate more resistance to the blood flow, and therefore the blood flow is inversely proportional to the viscosity of the blood.
Okay, now how about the length, Ash?
Okay, I can explain you that with the different lengths of the artery. Let's go. Now here Charm is holding two cups with two different straws. On the left side you can see a shorter straw and on the right side you can see a longer straw. And here I'm going to pour some blood to both the straws. Oh, it looks like it has failed. I'm really sorry that failed.
That's okay, Ashlesha. I think I get it, but I think I have an idea to demonstrate the length variable. Let's try that one.
Okay, let's go.
Now, shorter artery, it connects two cups, and here is the longer artery which connects to two cups. As you can see that this experiment works. Previous one might have failed because of the effect of the gravity. Here we can compare the effect of the length of the artery on the blood flow with the person is running from the distance between A to B and C to D. As we can see here, person can complete the distance between A to B sooner than the distance between C to D. Therefore, blood flow is inversely proportional to the length of the artery. Okay, Ashlesha, now I get it. All the parameters of the Poiseuille's law, how does it work with the blood flow?
Okay.